Payments are made to an account at continuous rate of 100 e to the 0.5t from times 1 to 3. Force of interest for this account is 8%. Calculate the value of the account at time 4. So here, the payment rate, the continuous payment rate is variable and the interest rate is constant. So we can apply equation 93.9 because this time we are not starting at time 0, but we are starting at time 1. So if you recall from lesson 93, we said that value at time c would be from c to c plus n. Normally it's 0 to n if you start at 0, but if you start your payments at time c, then the value at time c, because that time c becomes the current time, that's where the payments are starting. So it's c to integral from c to c plus n, the payment rate, times e to the minus delta times t minus c. Normally it's minus delta t here if you are starting at time 0, but if you are starting at time c, then instead of t here, you have t minus c that gets multiplied with delta. So that's the equation we will use. And since the payment rate is variable and the interest rate is constant, so this is case 4. And the equation 93.9 that we just saw gives the value at time 1. C is equal to 1 in this case. So it will be from 1 to 3. And the payment rate times e to the minus delta t minus c, so t minus 1. So the payment rate f of t was given to be 100 e to the 0.5t times e to the minus delta was 8%, so minus 0.08 times t minus 1. And now we can break up this power. We first distribute, and so we get negative 0.08t plus 0.08. And we can break it up into e to the negative 0.08t times e to the 0.08, and e to the 0.08 is a constant, so it comes out of the integral. And the 0.5t e to the 0.5t times e to the negative 0.08t, the powers add up. So 0.5 plus negative 0.08 is 0.42. And then we know that the integral of e to the ax equals e to the ax divided by a. So this integral will be e to the 0.42t divided by 0.42. Limits are 1 to 3. So you put in 3. 3 times 0.42 is 1.26. And 1 times 0.42 is just 0.42. And all this simplifies to 516.74. So that is the value at time 1. And we needed the value at time 4. So between time 1 and time 4, there are 3 years. If you go back to the problem, the value was needed at time 4. And between time 1 and time 4, there are 3 years. So we have the value at time 1. So the value at time 4 will be the value at time 1 times e to the 3 delta, because here it's just a simple moving of a value from one time to another. And if you have force of interest, you multiply the current value by e power delta t, where t is the duration, and the duration from time 1 to 4, like we said, is 3 years. So that's why it would be the current value, which is at time 1 times e to the 3 delta. And we substitute delta equals 0.08, and we end up with 657. That is choice E.